Hi everyone, it's my pleasure to be here at TM 2025. And today I'm excited to present the MoCha towards movie-grade talking character synthesis. This project is developed in a collaboration with the Meta Gen AI team. And I'd like to begin by thanking all the collaborators for their invaluable support. And this work takes a step toward the future of automated filmmaking. And we've seen new text-to-video models emerging almost weekly. And with examples like Kelin, Will, and Sora, Wenhu Chen, and these models are almost capable of generating production-level short movie film shots. And however, they primarily focus on generating non-dialogue scenes. And what about generating dialogue-driven shots? And dialogue scenes typically makes up 20 to 40% of the movie, and essential to making the characters feel alive and related to the audience. So can any current model generating convincing dialogue shots? So in this talk, I will set aside View 3 as it comes like 3 months later after MoCha. So at this time, the answer was not yet. This brings us to an important question. What are the unique requirements for generating high-quality dialogue shots?
So please, let's bring that forward. We humanize AI and immersion technology.
Here are the key requirements. And the model should be able to handle both single or multiple characters. So for single characters, it should be able to accurately sync lip movements with speech, and also control the appearance of the characters.
Technologies for building this.
And it can also manage different postures and also the facial expressions of the characters. And also we want to control the actions of the characters. And last but not least, the model should be able to control the camera movements, also handle a variety of shot types. For example, the close-up shot to a medium wide shot. And the model should also be able to handle multi-character talking scenarios. For example, there should be like one character talking and the other one is listening. And also can generating turn-based dialogue shots. Those are the fundamental building blocks for dialogue-driven scenes in films. And now let's take a look at what existing model or products can do. And we see two state-of-art models. They both developed by ByteDance. And the first one is called Loopy.
Sometimes it can feel like a tightening in your chest.
Giving autonomy to these agents.
Me? Yes, I would love to talk about something.
Yeah, if you look at their demos, so Loopy can support lip sync for a single character, but only within a constrained shot type. So it's like 1-to-1 aspect ratio with close-up shot and has limited head movements. And if you look at the more advanced model, the only human one, it can do lip sync and can do some degree of action controls, but the actions, the movement of the character is largely determined by the first frames. And in comparison, MoCha can address all of these requirements. So instead of just describing the results, I'm going to present a 1-minute video that I created by myself using the generation results from MoCha, and yeah, with some manually video editing. And yeah, so the shots I selected is not the best result from the generation results of MoCha, but I just choosing them because I think they tell an emotional, encouraging narrative, which like reflects the spirit of this project, also my personal journey on working on this project. And some of you may have seen this on Twitter, but I still want to show it because I'm really proud of it, the result.
Is life always this hard? Or it's just when you're a kid?
I said it before and I'll say it again. Life moves pretty fast.
Are you behind on your credit card bills? Good, pick up the phone and start dialing.
So tired of them being gone.
No such thing as spirit. We are made of matter, nothing more.
You have to be a boss, but you can't be mean.
You have to lead, but you can't squash other people's ideas.
Exercise gives you endorphins. Endorphins make you happy.
This part of my life is middle part is calm.
I just do one thing first. Then it's just us, music, and the road.
That is the question.
Don't ever let somebody tell you
You get a dream, you get a protector. People can't do something themselves. Let me tell you, you can't do it.
You are so beautiful. So smart.
He told me, keep your friends close, but your enemies close.
It's just about setting up the right team, and then overnight your life can change.
I think they stopped asking those questions here. For me, it was an AI leader.
What do you think?
My previous life, I was looking at
You follow my and stay here, do my own thing.
The fields, like the domains, whether manufacturing to.
And for more demonstrations, you can visit this website page. And also, I released a benchmark called MoCha bench, which includes more compelling results. And so how do we achieve this? And what exactly is the MoCha model? So from our architecture perspective, we keep things very clean and simple. So MoCha is a diffusion transformer-based model that generates videos directly from text and speech. Unlike all the prior approach, we deliberately avoid using any auxiliary signals. So there's no first frames, there's no face landmarks, there's no skeleton, no key points. So this set us apart from all the prior works, such as the loopy and omni-human we saw before. And during training, we also avoid using any masking mechanisms. There's no facial masks or lip masks to add inductive bias.
That doesn't make sense.
And instead, MoCha is trained end-to-end based on the belief that speech signal is rich enough, contain some information not only for lip movements, but also for facial expressions and co-speech gestures and full body movements. And our goal is to learn the mapping from speech to video directly from data. And technically, we use 3D VAE to compress videos into latent and then patchify them into video tokens, which are then processed by the self-attention blocks. And both speech and text conditions are projected into token space, which have the same dimensionality as the video tokens. And we use the cross-attention to fuse text into the video tokens, and we use this windowed cross-attention to fuse speech signals into the videos. And the key idea behind the windowed cross-attention mechanism is to achieve better alignment between the audio token and video tokens. So initially, if we assume each frame has a corresponding audio token, and this alignment is perfect, but after 3D VAE has a compression, it will compress pixels from multiple frames into a single token, and this alignment will be broken. So to address this, we introduce a strong bias. So we restrict each video token to a tens to only a window of nearby audio tokens. And this gonna help the model to recover the speech and video alignment. And and this design is very natural. So you can think about it in a video clip, lip movements and facial expressions are driven by short-term audio cues, and long-term body movements are more driven by the text descriptions.
The impact piece. what we do, I believe it matters.
Okay. And for the text signals, we include as many detail as possible. So here's an example. If you look at the right side of the slides, and we provide the shortcut. For example, here is a close-up shot of a woman, and the character postures, like the facing directions, and the character's appearance, and also the background details, and also the character's actions, and lastly, the camera movements. And by including all these details in our training data, during inference, we can achieve universal control over the generated content purely through text. And here are some examples, so we can perform camera control through prompting.
So today we can
clear that data
to build foundation models and be able to.
And it's true that I never saw anyone who looked like me in television or in films. And
to using very outdated training models. So that.
And here is it's about some demos about the expression control. We can prompt the characters to express different emotions.
you have to be a boss, but you can't be mean. You have to lead, but you can't squash other people's ideas.
Before we open up, maybe one questions there.
Not a footprint.
What I would like to say.
And here is an example, like we can perform fine-grained control of the character's actions.
I guess all of the things go down styles these days.
I said it before and I'll say it again. Life moves pretty fast. You don't stop.
Tired of them being gone.
We are Canadian and we want to.
Yeah, here is some more example.
This part of my life, this little part is called happiness.
Don't forget to check out my stories for those extra bonus codes that you're not going to want to miss out on, and all of the.
Yeah, this one is a good example to demonstrate MoCha can be used for advertisement. And also MoCha can generate portrait videos.
I had a dream, a wonderful dream, Papa.
I called everywhere in 5 states. I told them it was the only way to get my wife to marry me.
I made last night, it was a long night, and it was a great time, and I wish you could have been there, dude.
And now I'd like to explain how MoCha handle multi-character conversations. We have some special design for the prompting. So first we use a character tagging mechanism to keep the prompts concise and clean. So we begin by listing all the characters in the scene, each with a tag and a brief description. And then for each clip, we describe the scene efficiently by simply referring to these character tagging in the prompt. So if we don't do this, then without character tagging, and every time we refer to a character, we would like to repeatedly describe the character's appearance or the positions to let the model ground them correctly. And this not only risks exceeding the model's 245 token limits, but also increase the chance of confusing the video models.
So we know that we can use for some of our applications open source models.
And here are 2 examples that allow one character to speak while the other listens.
Don't ever let somebody tell you you can't do something. Not even me.
Better do it, or Aunt Laura's gonna pitch a fit. We should just get through it quickly. I mean, there's no skill involved.
Consider here. One is, as I said,
and because MoCha uses a fully tokenized design, it can support multi-clip video generations and in the exact same way as single-clip generation, so without any modification to the architecture. The only difference is that for multi-clip generation, the prompt now using the character tagging mechanism, and the speech signals comes from 2 different speakers.
If I can add something, risk
And
management
in this visualization, the first 2 seconds comes from speech comes from the person 1, and the last 3 seconds comes from person 2. And those speech are fitting into the speech encoder and projecting to speech tokens. And so instead of using video extension method that rely on auto-regressive generation, MoCha directly generating all clips in parallel. So we are not like generating first clips and then use them as the previous result and feed them into the model again. We just do the parallel generation at the same time. So, and MoCha use self-attention layers to make sure the characters are consistent and also ensure the coherence in the surrounding scenes.
Risks that we see today is most likely not going to apply to agentic, right?
We also observe that if we directly train this way, and the MoCha it learns by itself to using the switch between different speakers to determine where is the scene change, where is the clip change. So we don't need to add any like tokens, specific tokens to indicate the scene change. And here's 2 examples of turn-based dialogue.
What are you going to do?
I'm
going to follow my own plan. Stay here, get my own thing done.
You can see the woman speaking the first clip also appearing in the second clip, but facing away from the camera.
Baby, we need to get out of here.
I just need one thing first. And then it's just
There is a big difference. There are no bad risks as Gen AI brings into the space, for example.
And we identified 2 key challenges in training MoCha. So the first one is the issue of data scarcity and the limited diversity for speech annotated data. And speech annotated data sets are relatively rare and often lack sufficient visual and semantic diversity, which makes it challenging to directly train a model on it. And the second is the influence of speech on video generation depends heavily on the spatial scale. And in close-up shots, speech strongly drives lip and facial movements, but in medium or medium-wide shots, the video generation align more with the text prompt because the characters has more full body movements, and the speech influences diminishes in this setting. So if you train the model across all types of shots at once, it can lead to inefficiency. And so to address both of the challenges, we propose a curriculum-based multimodality training strategy. So we organize training into multiple stages based on shot complexity. So at stage 0, we pre-train on large-scale text-only data set to establish the strong visual priors. And then from stage 1 to stage N, we begin by close-up shots, and then which has the highest speech-visual correlation, and then progressively incorporate more difficult tasks, such as medium-wide shot or eventually the multi-character scenes. And at each stage, we reduce the proportion of the early examples from the previous stage by half. And we also maintain our 80 to 20% of the mixed modality data. So we always keep 20% of the data, 20% of the examples come from the text-only data. And this combination strategy allows MoCha to benefit from both text-only data and the limited speech annotated data.
The advancements in AI today.
And to evaluate the MoCha on dialogue shots generation, we introduced MoCha Bench, a benchmark tolerated for dialogue-driven scene generation tests. It contains 220 diverse samples, each comprise a text prompt and corresponding audio clips. And the data set covers a wide range of human activities and human-object interactions, and with characters speaking with different emotions and different facing directions. And we also have some zero-shot generation on different languages that the model has not seen during the training. And all the prompts are firstly manually crowded and then further enhanced by the large language models. And yeah, to enhance their expressiveness and diversity. And the benchmark is now available on Hugging Face.
It takes maybe time to move.
So the evaluation is conducted around those five axes. So we perform human evaluations on both MoCha and the state-of-the-art baseline models using MoCha bench. We assessing performance along each of the axes with a score ranging from 1 to 4. So a score of 1 means like a total failure, and a score of 4 typically means the generation results is almost indistinguishable from the TV or real movie characters. And on the slides, it's like a task definition of the dialogue-driven video generations. And you see the evaluation metrics across 5 different axes. And here is like a visualization of the benchmark results, and MoCha significantly outperform all the prior SOTA baselines. And with an average score approaching 4. And here is a qualitative compression to help illustrate why MoCha achieves significantly higher score in all the than all the baseline models.
I've been staring at the edge of the water long as
this is from the baseline model.
I've been staring at the edge of the water long as.
And it's worth noting that all the baseline models requires auxiliary signals such as first frame or key points. So to ensure a fair comparison, we use the first frame of the generation results from the MoCha, and then use them as a condition for the auxiliary signals for all the baseline models, and also the text prompt and the audio inputs. And we also conduct a ablation study on the curriculum training strategy using MoCha bench. We evaluate 2 baseline variants. So the first variant removes the curriculum training strategy and trains on short tabs simultaneously, and this leads to a drop in all aspect. And the second variant trains only on text, only on speech annotated data, which is limited diversity. So this variant also performs significantly worse. And it tends to overfit on front-facing talking head data and reducing the model's generation ability. And for the Sync C and Sync D, those are the metrics we evaluated using SyncNet. They're the metric used to evaluate the lip sync quality of the model. And the Sync C is the confidence of the, if you're giving a video and the corresponding audio, what is the confidence of them to be aligned. And also Sync D is the distance between those 2 inputs. So higher Sync C means better model performance. And lastly, for future work, it's natural to consider generating both video and audio directly from text prompt. And we see that Veo 3 can achieve this. And also I provided some, if you combine a text-to-speech model with MoCha, you can also achieve similar results. I provided one example on the website. And so basically you have your text prompt with with the content of the character going to see, and then you feed that into the text-to-speech model, and you generate the audio, and then use that audio as a signal for the MoCha model, and then you can achieve directly text-to-video audio approach. This is like a pipeline solution for it. Yeah, I think Veo 3 learns the model to generally generating video and audio. And another important direction is to extending the generating to longer videos. So this is gonna allow the talking characters to live longer and engaging in more complex interactions. And yeah, to conclude, MoCha takes a step toward the future of automating filmmaking by enable dialogue shot generation. And Yeah, thank you for attendance. I'm happy to take questions.
Hi. Well, first of all, this is really impressive. My question is, I can definitely see how this can be turned into like an assistant, you know, like, hey, Google, how do I cook squash ravioli? So question is, how much computing resources do you need for some kind of low latency execution? Also, do you have to like change the way you train a model like that so it would be like faster in inference?
So the computer required for training the MoCha, like 30B MoCha model is around like 1,000 H100 GPUs. But after this model is trained, you can definitely distill it into a smaller model that can run on device, and then can do the streaming of the talking characters. I think there's like an issue we need to solve, like how to maintain the character consistency across like, let's say 1 minute video generation. And yeah, there's still an open research question. How do you make your model efficiently handle that and also can have a infinitely long context input?
I think I might have missed something, but have you done a comparison using other benchmarks than MoCha bench? Like benchmark that already exists?
So I think the MoCha bench is the first benchmark tolerated for talking character task. There's no other benchmark before. And what all the prior work do, they just evaluating their results on a very small domain. For example, the SLAB-RE, which is an open source data set. And what people do is just random sample, like 200 examples from that small domain data set and evaluate on it. And we think it's not diverse enough. It has strong bias. So we propose this benchmark.
Any other questions?
Oh, my life.
I have a question. As NVIDIA's stock approaches a new all-time high of $146 a share, what kind of hardware, either data center or non-data center hardware, would you train something like this on? And what would be the minimum system requirement you would need to use to get the result that you've shown here?
I think in terms of the GPUs, it's like the 1,000 GPUs. And then I think for data processing, I using the internal data, they have a clustering from Meta, and then I can processing the data using like thousands of CPUs and to do the captioning and partition the videos and the filtering. I think that's a basic requirement.
They are, and that's
but with better method, like I think for this model we're using a flow matching loss. Maybe it's, like in a couple of weeks there could be another better method that can help better convergence for the diffusion models.